Hello guys, I'm Pratik. This is the first video of my How To series. In this video, I'll show you how to use 74HC245N as a logic level converter for 5V to 3.3V or 3.3V to 5V. So, this is Raspberry Pi 3 model. This is HCSR04 ultrasonic sensor. Raspberry Pi 3 is 3.3V compatible. So its logic level is 3.3V. Ultrasonic sensor is 5V compatible. So basically, to read these 5V data using Raspberry Pi, you need an logic level or voltage level conversion. Basically here we are doing it using 74HC245N. From 5V data of ultrasonic sensor, we are converting these data to 3.3V and read it using Raspberry Pi. I'll explain you all of the diagrams and connections basically. So this is our main 74HC245N. The first pin is direction, the last pin is ground, the 11th pin is B7 and the 20th pin is VCC. This direction pin is an input pin basically. This A0 to A7 pin is input pin or output pin. You can use that input or output. This B0 to B7 is same as a A0 to A7. You can use it as a input or output. This 19th pin is output enable pin. It's input pin. 20th is VCC. Basically you will connect it with system voltage. Now this is the first pin of Raspberry Pi, 3.3V, and this is the second pin is 5V. This is ground for Raspberry Pi. This is the two GPIOs I have used. These are the two pins of Raspberry Pi. These are the two GPIOs I have used. So here I have connected trigger pin to one of the GPIO for Raspberry Pi directly, because these 3.3V will detected as a high by HCSR04, which is an ultrasonic sensor. So you don't need to convert these 3.3 to 5 here. But for eco, you can't read this 5V data using Raspberry Pi. So you need to convert these 5V to 3.3V. Here I have connected this eco pin to B0 pin of our IC, and this is the A0 pin which I have connected to one of the GPIOs. So now whenever this 5V data will come, it will be converted to 3.3V and we will read it using Raspberry Pi. Now I'll explain you how and why I have connected this direction pin to ground and this VCC pin to 3.3V. Here you can see that output enable pin and direction pin, if you will make them low, then B will work as an input and A will work as a. So here I have done the same thing. I have made these direction pin low and this output enable pin is also low. I have kept both of them as a low. Here B will work as an input, so basically we are getting 5V data here, and A will work as an output, so we are getting 3.3V data here. And I have connected this VCC to the 3.3V. You have to connect it with 3.3V, then and then you'll get 3.3V output data here. So this is the GPIO header for Raspberry Pi 3. You can see here this is the first pin 3.3V and this is the second pin 5V, and these are the two GPIOs I have used, which is GPIO 16 and GPIO 17. GPIO 17 for trigger and GPIO 16 is for eco. Now you are thinking that if you want to use it with 5V motor driver or like LED or anything else, then because here it's like 3.3 5V to 3.3V conversion, if you want to use it with like 3.3 to 5 volt conversion for 3.3 volt to 5 volt conversion, then okay, I'll explain you. Here I have used L293d, which is a DC motor driver, same as previous slide. It's 74HC245N, but the connections are different. I'll explain you. So here I have connected direction pin 5 volt and output enable pin to. Here you can see that direction pin high and output enable pin low. So A will work as an input and B will work as an output. So here I have connected direction to high and output enable to low. So B will work as a output and A will work as a input. So here I'll give 3.3 volt signals, and from here I'll get 5 volt signals. Now I'll explain you how I have connected L293d. So basically this is the pin diagram of L293d. The first pin will work as a enable pin. The second pin and seventh pin is input. Third pin and sixth pin is output. So second pin and seventh pin will connect our output of microcontroller, and at third pin and sixth pin, which are basically output pins, will connect our DC motor. Here you can see that if you will make enable pin high, then you will get output according to your input. If you will make enable pin low, then output will not get any output. Basically it will go into the high impedance state. This VCC2 pin is the pin where you have to connect to your motor driver's voltage. Basically, sorry, it's your how much voltage you need for your motor. And VCC1 pin is your basically microcontroller's voltage, which is 5 volt in our case. I have connected VCC2 with 9 volt because my motor is 9 volt specified. So now this is the first pin of L293D, which I have connected to the 5 volt. It is enable pin. This is second pin, which I have connected one of the GPIOs. This is the third pin, which I have connected to the motor. This is the fourth pin, which is ground. Fifth pin is also ground. Again sixth pin is output, green one. This is seventh pin, which is input. I have connected to the GPIO of controller, and the last pin is ground. This is VCC pin. I have connected to it 5 volt. Sorry, this last pin is VCC2. Yes, this is VCC2. I have connected it to the 9 volt here with battery. Again these two pins are ground. So here I have used some of the GPIOs. You can see here in diagram. Now I'll explain you overall function of it. Whenever you will trigger these two pins, for example, if you will make this gray GPIO high and this yellow white GPIO low, so this 3.3 voltage will be converted in 5 volt by our 74HC245N IC. Now these 5 volt will go to the input pins of L293D. So this motor will rotate in one direction. Now suppose if you will make these voltage opposite, if you will make white one is high and the gray one low, then the direction of motor will be reversed. Basically motor will work as a 9 volt. This 5 volt is for our motor driver and this 9 volt is for battery. Basically L293D is a H bridge. You can read it more about in its datasheet. I'll provide you link for it in description. So now you can implement 74HC245N in your projects. It's very cheaper than modules available in the market because it's 8 channel. You are getting 8 channel here at almost half price of logic level converters available in the market. This is the header for Raspberry Pi 3. If you have any questions, you can ask me in comments. Thank you.